Okay, for this assignment, we're going to be working on the law of sines and the law of cosines. But before we start the law of sines, I first want to solve this oblique triangle without using the law of sines. And what that means is that I'm going to have to break it into two right triangles. So I'll start by dropping a line down here that's perpendicular to the base. And now I have a right triangle here and a right triangle there. I can solve these two triangles together to get everything on the larger ABC triangle. So this 3.241, I'll consider that the hypotenuse of the right-hand triangle, and I'll actually draw it down below here just as an individual. So this is 3.241, and this angle is 54.25 degrees. I'm going to label this the hypotenuse. This is the opposite side from 54.25 degrees, and this is the adjacent side. So now I'm going to use the sine and cosine functions in order to calculate the opposite and adjacent sides. So here we have the sine of 54.25 over 1 is equal to the opposite divided by the hypotenuse, SOH. So cross multiply and divide here says that I'll take 3.241 and multiply it by the sine of 54.25. So that's 2.63. All right, then I'll do the same thing with cosine. So I have 3.241 times the cosine of 54.25 is 1.89. All right, so now I have everything on that right-hand triangle. Now I can use some of that information to calculate the left triangle. All right, from above, I know that the 40.25 is the same down here, and this is my right angle. I already calculated the 2.63 on this side, so I'll just transfer that over to this side. Now that 2.63 is the opposite of 40.25. This would be the adjacent, and this would be the hypotenuse. So what I'll do here is use the tangent function and the sine function in order to calculate the hypotenuse and the adjacent. Tangent is opposite over adjacent. And sine is opposite over hypotenuse. All right, so now I'm going to go to my calculator, and using that 40.25 degree angle, I'm going to calculate 2.63 divided by the tangent of 40.25 to be 3.11. And 2.63 divided by the sine of 40.25 is 4.07. All right, finally, I just need to transfer this information back up to the original triangle. So this is 4.07, and on the bottom, I'm actually going to add the 1.89 and the 3.11. So we get a distance from here to here of 5.0. Last thing is to calculate the angle on top there. And to do that, I use the fact that a triangle still sums to 180 degrees. So this would be equal to 180 minus 40.25 minus 54.25. Which is 85.5 degrees. Circle my 3 answers here. And just a couple of notes. Because this is not a 90-degree triangle, if you look at the overall ABC, the Pythagorean theorem is not going to work on it. If you tried, the Pythagorean theorem would not show that a squared plus b squared equals c squared. That's not going to hold true. And you can't use regular sine, cosine, and tangent on the overall triangle either. That's why we had to break it into 2 right triangles so that we could use our SOHCAHTOA to solve it.